So welcome. Thank you so much for being here today with us at our Malama Pūpūkea-Waimea Marine Science Talk Story, Science and Management of the Pūpūkea Marine Life Conservation District. So to get started this morning, we'd actually like to share an oli with you. And this oli is one that was written for us here at our area. And we put the words there up on the screen for you in case you'd like to see kind of what we're talking about. I have Palakiko with me here in the background, and so he's gonna, that's the other voice that you will hear. Eyala na kia I o neia ina hiva hiva heva hipana he pu'uhonu ai o ino kanui le hule o Pūpūkea o ke kailako o Waimea o ka wai ka he mahu o kanaloa o kai o ke kaimalino I ke kaue o ke kai po'i ka ho'oilo e o mai hina o puhala ko a o ka papa e ia ho'i nā mea e oni pai nā mea e hi poi ka aina no nā kaua ka ukui ka ha'a a poi ka mala mai o ko mako aloha kei. Okay, mahalo for sharing that beautiful oli with us about our place and the things that are so special about our place. So what I'd like to do is I'm actually going to pass it over right now to Debbie Goen-Smith, who is Malama Pūpūkea-Waimea's kako'o, the person who really helps us with everything. So Debbie, take it away.
Mahalo, Jenny. Nice to see everybody this morning. Aloha kakahiaka. And welcome to our Marine Science Talk Story. Thanks for everybody being here today. Malama Pūpūkea-Waimea is a homegrown North Shore community-based nonprofit organization that came together starting in 2005, although the work of Malama Pūpūkea-Waimea predated that 2005 meeting. That was the first time that the folks that currently comprise this organization got together. And their mission is to replenish and sustain the natural and cultural resources of the Pūpūkea and Waimea Ahupua'a. So I just want to say thank you to Jenny. She's MPW's one staff member, and MPW is also fortunate that she recruits Palakiko, her husband, and then often La'a, her son. So MPW gets 3 for 1 there. Palakiko is also on MPW's advisory board, along with some other folks that are here today. So thanks to them. I also want to give a shout out to Christy, because she supports MPW through the Native Hawaiian Plant Coastal Restoration Project that she helps to steward. So thanks, Christy, for being here and for all that work. Other work that Jenny does and leads for MPW, education and outreach at the MLCD, coordinating things like today's Science Talk Story, coordinating other outreach and education events on behalf of MPW, and then coordinating volunteers for Makai Watch. So this is where we partner with the Division of Conservation and Resources Enforcement and DAR to help provide good stewardship of the Pūpūkea Marine Life Conservation District. Also I think Samantha, sorry, I'm sharing screen, so I only see a little strip of faces, but I think I saw Samantha Mislinski on today, and she is MPW's science coordinator. And she's been working with MPW for the last few months to help with our citizen science efforts, so human use monitoring and biological monitoring at the MLCD. So nice to see Samantha here today. Before Samantha was Keelan Barcina, and he's now at the Office of Planning, but he was MPW's first science coordinator. I also just want to acknowledge board members that are here today. So I know President of the board, Denise Antolini, is here. I think Uncle Bob is supposed to be here. Again, can't see everybody's faces. Sydney Covell and Jackie Linau as well. And then Uncle John Cutting, who's our emeritus board member who's here today. So nice to see you again, Uncle John. MPW partners with a lot of different groups. And DAR is one of the big ones that we were partnering with. Part of the reason we are working with DAR these days is to create a management plan for the Marine Life Conservation District. So the MLCD is more than 30 years old and has never had a management plan, and this is an opportunity under the Holomua 30 by 30 effort. So we're excited to have all of these different scientists here today to help us make sense of the science for management purposes. So that's part of what MPW is working on as well. And I think Jason Malinger from DAR and Stacia Marco is supposed to be on today as well. So thanks for you folks to being here as well. If you're interested in beach cleanups, biological and human use monitoring, citizen science efforts, Makai Watch, the email is on your screen there, info@pūpūkea-Waimea.org. That'll get you in touch with Jenny, and yeah, love to have you volunteering with us. Jenny also runs a couple of educational programs, Kapapakai and Lawaiʻapono, which is for middle school and high school youth to learn how to fish responsibly. So please, yeah, feel free to check out our website at pūpūkea-Waimea.org, reach out to Jenny or others that you see here that you know, and get connected with MPW. Also would be remiss if I didn't say mahalo to a couple of funders that help to support the science and the management planning efforts that are happening. So mahalo to our local North Shore Patagonia store. Got a grant from those folks. And then also WSL Pure helped to fund science and management planning for the MLCD. So mahalo to those as well. All right, before I introduce our esteemed panelists, we asked a couple of questions during the registration process, and it's always nice to see what happened with those polls. So I wanted to show you what you all believed are the key threats to the Pūpūkea Marine Life Conservation District. You can see that human use is clearly the leader among folks here who registered for this event. There's concern about human use, also runoff and groundwater, global warming, and then a few people poaching, shoreline erosion, and other. We had a late registration this morning, so other should actually be 3. And the other things that people listed were ignorance and an anti-pono ethic, plastic and trash, and commercial dive and snorkel tours. So those were of concern to folks. So that's what you all said. And then we also asked about the science you'd like to see for the MLCD. So we put those into a word cloud here, say the majority of people who responded wanted to see additional studies about human use and carrying capacity, biological carrying capacity. There was also interest in impacts related to water, groundwater, nutrient loads, those kinds of things. And another popular request was about marine life, limu, fish, corals, and so on. So the good news is that some of you are going to be able to learn about some of those things today, and we appreciate ideas for what to study next. All right, so the way things are going to run today is we're going to hear from our scientist guests, and they're each going to give a presentation of 7 to 9 minutes or so. And after we have these different presentations, then we're going to have a discussant, and I'm going to go over this in just a minute. We're going to have a discussant, and then I'm going to ask some questions of our panelists today. Then we're going to give them an opportunity to ask some questions of each other. I am going to, if Stacia's on, I'm going to give Stacia an opportunity to ask a question as well. And then we're going to get to some questions in the chat. So because we've got all of these different presentations, instead of doing Q&A after each presentation, which we're afraid time will get away from us at that point, We're going to ask that you put your questions in the chat or hold them to the end, and we'll save some time to get questions from the audience as well. Again, the purpose, or our purpose in hosting this Marine Science Talk Story, was because it's really unusual for us to have an opportunity to put scientists who've been working and doing studies in the MLCD in one space and have them listen to each other, so that, you know, what the fish folks do and what the water folks do, they can hear what each other has to say and then help us make sense of it for management planning purposes. So that's what we're aiming for today. Okay. If you have any questions, put them in the chat or unmute and let us know if you don't understand about what's happening. Otherwise, I want to spend no more time on that, and I want to get to who our panelists are today. So we are super, super excited, both that all of these folks have taken time to do studies in the Marine Life Conservation District and bring their knowledge of the MLCD and also their knowledge of places around the state and around the world that helps inform their understanding of what they see at the Marine Life Conservation District. So mahalo to all of you so much for the science that you do, the work that you do, the contribution that you make, and for being with us today. We're going to start today with Dr. Alan Friedlander, who has, I think he's done probably the more studies in the Pūpūkea Marine Life Conservation District than any person living or past, present or past, I would guess. So we're super excited, and he's actually on MPW's advisory council as well, or advisory board. So grateful for Alan. And after Alan, we're going to turn it over to Paul Morikawa and Laura Gajdik, who are both with Division of Aquatic Resources and have several decades worth of studies in the MLCD that they have access to and have been involved with. So we're really excited to hear about that as well. And then our very own Jenny Jagodish, who is a practitioner of KILO, close observation, close consistent observation of the Pūpūkea Marine Life Conservation District. And she's a limu nerd. That's her words for it. I'm not talking smack. So Jenny's going to talk about limu in the Pūpūkea MLCD. And then just finished up, Dr. Daniel Martini and did some 3D mapping of Sharks Cove. And we're really excited. Some of us haven't ever seen the results of this before. So we're super excited that he's here to share that study with us. And then Robert Walker is going to talk about groundwater. And that's going to be related to the next presentation with Henrietta Dulai and her student Austin Ramos at the University of Hawaii to also talk about groundwater. Then we are really, really excited to have Kostas Damolos with us today, because he is going to help us start to translate what all of this means around human use specifically. So he's listening to these presentations through the lens of human use and human impact to the Marine Life Conservation District. So he's going to be our first discussant after these formal presentations. And then we have some questions that we're going to ask our panelists, okay? So thank you so much again for being here, everybody. And I'm going to stop sharing because we're going to turn it over to Alan Friedlander.
Okay, great. Can everybody hear me? Thumbs up. Good. Awesome. So aloha, everyone. Mahalo for coming. I'm excited to share some results that from work we've been doing in Pūpūkea for the last 2 decades or so. I'm chief scientist for National Geographic Pristine Seas, trying to save the last wild places in the ocean, but also a researcher at the Hawaii Institute of Marine Biology. So I've worked everywhere from South Point to Kure in the Hawaiian archipelago. So I have a pretty good perspective of what things look like in different places. And as Debbie mentioned, I'm also a member on the advisory board of Malama Pūpūkea. So The Pūpūkea MLCD was established in 1983, and it was pretty mini at the time. It was a little less than 11 hectares and only consisted of that area in red, the polygon there, which was Sharks Cove and 3 tables. Tide pools are not included. There were a lot of community concerns about overuse, poaching, tourism, and there was also a lot of biological concerns about overfishing, lack of good habitat. And so through a community-driven process, a lot of people involved in that on this call, partnering with DAR, DoCare, Community Conservation Network. The MLCD was greatly expanded by 7-fold in 2003. And I had the privilege of being a little bit a part of that process. And I think everybody's efforts on that greatly improved what the MLCD looks like today. And what it looks like today is a lot different. So in 1983, when it was pretty small, the dominant habitat in blue there was rock and boulder. And what we see is after expansion, you get a lot greater diversity of habitats. So we've got sand, we've got rock and boulder, we've got pavement habitats, intertidal habitats. So it just made for a better MLCD by having a greater diversity of habitats. It also had a greater diversity of cover. So in 1983, the vast majority of the bottom cover at Pūpūkea was macroalgae. Not always the best thing you want to see. And so with the expansion, we've got uncolonized habitat, turf algae, macroalgae. Coral cover is about 12%, and that's pretty typical of most North Shore locations around the state. So including that into the MLCD was really key. The depth greatly expanded to, by about 5 meters. The slope increased. The variance in slope, or the amount of complexity in the habitat, almost tripled, 2.5 times greater after expansion. So basically, everything got better as a result of making the MLCD much bigger. And I'm sure Daniel's got some better imagery, but this is some old work that we did on 3D analysis of so this shows pretty much the bathymetry, or the bottom topography of what it looks like from Heiukai almost to Chun's. And those little red dots represent places that we sampled for fish. The bubbles are proportional, so the bigger the bubble, the more fish. And you can see that pretty much all of the fish biomass is within the shaded area there, the Pūpūkea MLCD, and much less so on the outlying adjacent areas. Okay, this is some work we completed recently looking at all the marine protected areas around the state. So 31 of those had good biological data. And what we see is Pūpūkea MLCD shows up pretty much in the middle there, and it's at the low end of fully and highly protected areas. So fully and highly protected areas perform much better than places with medium or low levels of regulation. So you see Kalapapa, Ko'olave, Old Kona Airport, those places all have high resource fish biomass. Pūpūkea sits at the low end of that, probably mainly because it's on the island of Oahu. Like you see, Waikiki MLCD is the same way. So you can get in a little bit more of that in the discussion. This is hot off the press because we just finished sampling this summer, like 2 weeks ago, myself and Whitney Goodell, my colleague and former student. And basically, the dominant players within the MLCD are Maiko'iko, which accounts for about 21% of the total biomass. And that biomass is 85% greater than the outlying adjacent areas. Uhu'elele is second at about 12% of total biomass, and a 93% difference between inside and outside. Na'e, the orange band surgeonfish, about 9%, and also a big difference. And Nenui account for about 5.6%, and also a big difference inside and outside. So I broke this down into resource fish and non-resource fish. Resource fish are things that we eat. So those are the things that people mostly care about. And you'll see that biomass, that black bar there, is increasing every year since expansion from 2003 to 2016 or so. We see a big dip in 2020, there was a lot of poaching going on during COVID. People need to feed themselves, their families. So there seemed like there was a lot more poaching than there had been in the past. And in this last data set that we just collected the other week, we see a slight increase in biomass relative to 2020, but once you bang things down, it takes a little while to recover from that. And it wasn't proportional among all the species. So herbivores account for the dominant biomass, myco-eco being the dominant one. You see there, that's the green bar. So we see a big drop in 2020 with the herbivores. The brown bar is the invertebrate feeders like moana, the goat, other types of goatfish, veke, things like that. They've maintained pretty stable. The predators, the red there, like omilu mainly, they actually increased starting in about 2008, took a little dip, and now they've come back. And then the planktivores had a big bounce. That's mainly things like mamo, things that people are less interested in from a food perspective. I think the main culprit here is uhu'elele. So what happens is, so they change sex, right? So the females are uhupaluka, and then the males are uhu'elele. And the females are the black bars, the males are the red bars. This is size structure of animals over time. And you'll notice that over time, we're starting to see an increase in the overall size and an increase in the number of males in the population. So that's a good thing. Starting in 2016, we see kind of a real absence of these guys. So poaching was taking place well before the COVID epidemic. And now what we see is very few uhu'elele in the MLCD. And I attribute most of that to poaching. Okay, lastly, we're starting to focus on the Kapō'o tide pools. These have recently been included within the MLCD thanks to the great work of Malamba Pūpūkea-Waimea. And this is an important habitat for a bunch of different species. Pualu, manini, and a bunch of the mullet. Also see big schools of hole there. So it's an important habitat. It's a good nursery habitat. It's important for bait fish too. Things like nehu are often found in there. So including these habitats has been critical. And I think we need to think about managing human uses within this area to better, because they're all connected to the offshore areas. A lot of the species are recruiting to the tide pools. And then as they grow, they're going to be into the deeper water habitat. So including those is critical for maintaining or improving the overall integrity of the ecosystem. So I did a quick drive-by there because I want to give everybody else time, and we can talk about more of this in the discussion. But I'm pretty stoked that we're able to get this last set of sampling in the last few weeks before the swell started to hit. And we'll try to keep doing that as much as we can over time. It's a big effort, but I think the data are really valuable, and taking this long-term perspective on it, I think is really critical. So mahalo, everybody. And I will stop sharing my screen at this point.
Mahalo, Alan. I can't imagine how challenging it must be to take a couple of decades worth of research and try to fit our parameters of 7 to 9 minutes, but man, you did it. So thank you so much. And I know people have questions. Please continue to add your questions to the chat, and if we can answer them as Jenny is trying to, we'll catch them there. Otherwise, I'm taking notes as well, and we'll add them to our list of questions for the panelists as well. So, wow, that was an awesome start. So I'm going to turn it over to Paul and Laura with Division of Aquatic Resources. And yeah, I'm excited to hear what you all have to share. So you can go ahead and share your screens.
Yeah, so Alan made my job a lot easier. A few of my slides was about the establishment and the boundary increase. So once the slide comes up, I can start my talk. So basically, you saw from Alan's presentation, the green line is the old boundary. The yellow line is the DJ surveys that we used to conduct starting from 1982, actually before the establishment of the MLCD. For 20 years, that was the boundary. These yellow lines are 750 feet long by 40 feet wide. So each surveyor had a swath of 20 feet that they had to count all fish, size to species, and length in inches. Next slide, please. So the next slide, you can see the boundary changed. It got further offshore. So we established permanent sites. Instead of running our cotton string that we used to use, we established permanent sites at the yellow thumbtacks. These are 25-meter belt transects, similar to the WAP method that Dr. Bill Walsh used on the Big Island in Kona. 4 25-meter belts, 4-meter SWAT. And on top of these, we have 4 5-minute time swims. We use a GPS unit attached to a float to get the distance covered during the 5 minutes of our swim. The belts, like I mentioned, is 4 meters wide. The 5-minute surveys are 5 meters wide. So each diver covers a 5-meter SWAT. Also at these yellow dots, we do a benthic component, which is once every 3 years. We take photos along the 25-meter belts. We also do rugosity. So that measures the roughness. Alan kind of mentioned a little bit of this, but we measure the roughness of the area. And, you know, at a minimum, if it's flat, then it's going to be 25 meters along the 25-meter belt. But if it goes to 28 meters, that means there's a plus of 3 meters. So the roughness is technically, 3 meters. Also, you see on the screen, these green thumbtacks. Those are just randomly placed 5-minute swims. So we have a total of 8 25-meter belts that we do and 16 5-minute swims that we do on scuba. I wanted to add that, like everyone knows, this is the North Shore of Oahu, and it's only during the summer months that surveys are possible. During the DJ surveys, it was probably once a year kind of thing. We try to do it at the beginning of summer and at the end of summer. So at least have 2 replicates within that time period. Also on the screen, you can see the red thumbtacks. We started these in about 2013. They're a snorkel survey, but we follow the same method as the scuba 5-minute time swims. We count all fish in a 5-meter SWAT, towing a float to get the distances. Basically, this is just to compare the inshore and offshore data that we're gathering. Next, please, Laura. And then, like Alan also mentioned, in last month, the Kopo'o tide pools were added to the MLCD. So you can see in this image, the 2 red thumbtacks is our 5-minute snorkel time swim. We're still in discussion with the crew and people on this panel to get some further insight as to if a 5-minute swim or some kind of different monitoring method, maybe a castnet survey or something could be possible within the tide pools. Right now, I think that's my last slide, and I'll pass it over to Laura.
Hi, everyone. Sorry, we cannot see. I think that will be a bit better like this. Sorry, Paul. So as Alan mentioned, we're starting right now to look at all fish species with the new type of survey that Paul mentioned. But before, since the 2080s, we were really focusing on resource fish, so those important for food or have a cultural value. So in this presentation, we're just focusing on these 13 fish families. So I guess you're familiar with the barracudas, our jacks with omilu, the sea chub with the enueni, the snappers with uku, tao, taipei, the parrot fishes are whoos, the wrasses, certain fishes with manini, and so forth. So I'm just going to show you, this data are coming from actually Alan's paper and Paul, and from our data from DAR. So here you have the resource fish biomass on the y-axis, on the x-axis you have the different years. So I just indicated a different type of fish transect than Paul mentioned. So from 83 to 2003, we have the DJ method. Then we switch from 2007 to 2017 with permanent transect, where a surveyor goes every year, like Paul mentioned, to survey the same sites. We also have the 5-minute survey, which are specifically dedicated to resource species. And we have the snorkel survey that DAR added in 2013. So the most important message from this figure is to look actually at the trend, which is in the black line, and the gray area is just the uncertainty. And what you can see is that the biomass remained quite similar from 1983 to 2003. Then we have this increase in protection with more sites, and you can see that the trend is increasing, especially starting from 2015. So I only have data from 2017. So Alan presented some more data to 2020. We were wondering maybe if this increase in fish biomass is due to certain fish groups. So we can look at this in this multidimensional space. So each actually number represents a date. So the fish biomass for 2012 is written in 12, 2010 for 10, and so forth. And so most important is we can see there's a spatial segregation. When the earlier years, we had actually more wrasses and more sturgeon fishes that were more abundant. And then in the later year, on the top right, we actually have a shift in species composition with more whoos, more jacks, and more snappers. And in 2012, we have more mullets. So maybe those changes could be due, for example, to differences in recruitment to some pulses. So here you have some data with the color that represent the 13 fish families, and the year are still on the x-axis and the biomass on the y-axis. So most important is to look at the proportion of the different colors. And so for the recruitment on the left, you can see that we had more mullets. It appears that we might have some pulses in mullets in 2009 and 2014. And we actually have in 2017 more recruitment of wrasses and who on the purple color and wrasses on the red. And so from some of the data, we can look at this time frame from 2007 to the right in 2017. And again, when we can see some variation in biomass over the year, but the proportion for each fish families remain quite stable. So we can see different colors. So as a take-home message, sorry, I need to change this, is that, I mean, the fish biomass has been increasing, but as Alan mentioned, there might have been some poaching due to COVID restrictions. So we will need to see in the future whether the biomass bounce back. What's more important is that it's really interesting that we have a similar proportion of different fish families, but Alan shows it varies for trophic groups. And that most importantly is that we have more whoos, which are very important to keep our reef clean because they're removing algae that can overgrow over corals, and they can keep our reef healthier.
Okay, so this is our contact information if you want to get in touch with us. And if you see this boat out there, don't throw rocks at us or don't call DoCare. It's just us monitoring, doing our twice a summer monitoring. And that's the end of our presentation.
Wonderful. Thank you so much, Paul and Laura. That was really fascinating. Thanks for the takeaways. That's helpful too. So many questions. So please, folks, continue to put your questions in the chat, and we're going to be, harvesting and gathering those as we go along. But next, we're going to hear from MPW's very own Jenny Yagodish about limu.
Thanks, Debbie. I was getting so excited listening to all the presentations, I forgot what I was talking about. So what am I talking about? Diversity and abundance of limu in the Pūpūkea Marine Life Conservation District. So what we're going to do is we're going to just go through this fairly quickly. With limu, there's so much to talk about. So I've just sort of put the nitty-gritty together just to give you all a broader understanding of what the limu health and diversity is looking like currently in the Marine Life Conservation District. But we actually started monitoring officially, and by officially, I mean we started doing repetitive kilo where we were paying attention to all of the details and starting to figure everything out Really started that in 2015 in April. The photo that you're looking at here was taken that day, that first day. This is Uncle Bob Laynell here, and this is Uncle Wally Ito. Uncle Wally Ito worked with Uncle Henry Chang Wo of the Eba Beach Limu Project. And while Uncle Henry Chang Wo wasn't healthy enough to physically get out on the reef, he did look over the photos and the images that we were able to capture that day. And he was able to help verify which species we thought we had. And so that first survey, we identified about 20 different species of limu. We determined that the limu was overall abundant and that it was predominantly native, which was really good, and that there were adequate invertebrates on the reef that were helping to enhance the habitat for the limu. And we began to track the moon phases, the tides, and the seasons. So speaking of seasons, what was really interesting is when you look at this area, and this reef flat here is Pūpūkea-Waimea, and this is one of the areas that we use sort of repetitively as a guide for the entire MLCD. You know, the MLCD is total of roughly around 100 acres, and about 2 acres of that, very small percentage of it, is sort of this reef flat habitat where more limu diversity can really be abundant. And so this particular reef flat is one that we chose because it's kind of contained and we can really monitor it in time and, you know, really look at it. It's very, all the other reef flats throughout the Marine Life Conservation District are very similar in makeup and very similar in species. So that's why we're at this one all the time. But limu is very seasonal. And so when we look at this reef flat, this is an image taken in January. So North Shore has huge winter surf. Paul mentioned that, you know, it's very volatile on the North Shore, especially in the winter time. But the limu seems to really grow and be abundant during that rough surf period. And so this same reef flat, so this is January winter time. In March, the waves start to die down, but the limu is still there. We're still able to see limu, and then now we can physically get out there and start looking at it. A couple of months go by as we start to move towards summer. We start to see a little bit of dieback of the limu. You can see that starting here on the inside where it just get less coverage. Then we get into summer, and basically there's this dieback that just naturally happens, and just about all the limu that was there a few months ago is gone. And then towards the end of the year in October, what happens is you start to see more rain and a little bit more surf, a little bit longer days, and shorter days, excuse me, and you start to see some limu starting to come back, especially on the inside with an increase in green limu due to the fresh water from the rain. So when we talk about invertebrates helping habitat, what we're talking about are things like these helmet urchins or ha'uke-uke. And what they do out on the reef flat is they actually scrape and clear the algae and other stuff from the reef, and they create space so that limu, which reproduces a lot by spores, those spores have somewhere to settle. And so in a marine life conservation district where all of these species are protected, we see a nice supply of these grazers, and so that is one of the reasons why we see a nice supply of healthy limu. So what kind of limu are we looking at? What kind of limu do we have out here? We've got a whole bunch, and so I don't have time in this presentation to go over each individual one with you, but here's a look at what we have documented so far. It's about 35 different species. We have them separated for you with the red limu, green limu, and brown limu. And unfortunately, like I said, we don't have a whole lot of time to spend on this, but in the future, if anyone is interested, we can go over these individually for sure. So what does it look like at the reef as a whole? And so, you know, what is the ratio that we have here? So what I did was I took a look at limu coverage by percent and type, and using, again, Pūpūkea-Waimea as a model. And so dominant species, when it's in season, is limu kala. And so what you're going to see is that at some times it's like a carpet of limu kala out there. I mean, there's just so much. It's wonderful. It's beautiful. And some of the sprigs of kala can be 1.5 feet, almost 2 feet long at their peak. And it's really beautiful to see. What's cool is we have pretty much all the species of limu kala out there, definitely more than just one. The next thing that you're going to notice is sort of other native, and then we'll get into non-native coverage. But other native, this is actually an interesting bed. of Dikyota that is happening inside the middle of Waimea Bay, and it just kind of pops up seasonally. It's vast. There's a lot of it. It's very short-lived, just in the summertime, but it's kind of cool to look at. Non-native, and we're looking at proportion here. So now we're down to about 13%, 12.5% of the coverage overall is non-native, and so this isn't the best news. But when we saw this happening, what we did is we went straight to DAR and asked for a special activity permit so that we could remove those 2 non-native species before they had a chance to become invasive. So we started that in 2019. We're on our 3rd permit now, which will take us through the beginning of next year. And overall total, we've removed, and Christy, who's on here, I told you guys she was my left arm. There's Christy. We've hand removed about 50 pounds of the prickly and about 40 pounds of the hookweed. And so what does that look like? Well, we get on our hands and knees, and this is what a before looks like, and this is what an after looks like. So we must know what the natives are so that we can kind of hand pick through and make sure that we're only pulling the correct things. And then we actually have this relationship with our Native Hawaiian Plant Coastal Restoration Project, where we take that limu off-site, compost it, get it down into mulch and nice healthy ingredients, and we put it back into our Native Hawaiian Plant Coastal Restoration Project for nutrients. So back over here onto our chart of coverage, pepeao is very abundant, sort of the first thing to come back after the dieback. And so that's when we'll see a lot of pepeao. Loloa is a beautiful red limu that pretty much just lives in this hole on the reef right here. We also have paulahalaha, which is that bright green lettucey one that all the honu like. And we'll see that one along the edges. So it's not overall taking up a whole lot of coverage total, and kahili as well. And we get down here to the last 2. And so I want to talk about these for just a quick second. Limu kohu and limu lipe'epe'e make up a very, very small amount of what's out there. And what's interesting about that is, this is limu kohu. What's interesting is there are 2 limu that you are allowed to take from the Marine Life Conservation District. Limu kohu is 2 pounds per person squeezed dry. And if you're familiar with this limu, it's very fluffy, and squeezed dry, it loses a lot of volume. It takes a lot to make 2 pounds. So here's a look at the reef flat here. This little bit here is limu kohu. So there's a lot of other limu around besides kohu. And then just to give you guys an idea of how much that limu is, here in the center, this solid softball size ball of limu here is about 1/2 pound. It's about 8 ounces. So if you can imagine 4 times that per person per day, there's not that much limu there to be had if everyone were taking that amount. Based on that one reef flat alone that we were looking at, you probably would not be able to reach your daily allotment if you took everything off of Papakaha'ohina at one time. 2 pounds is enough for me for a month, and I only go once a month at the most, says Nalani Kaniakua, who is a lemur practitioner and a caretaker of lineal limu beds on Kauai. So she said that was a whole ton. So anyway, I just point that out because it's one of the ones we have so few of. Also, same thing with limu lipe'epe'e, same allotment, 2 pounds per person squeeze dry per day. And those are a combined total of both species, by the way. But as you can see here with a finger, this is the limu lipe'epe'e here. It's very small and it's very tiny, and there's not a lot of it. You really have to go to find it. So my point being there is that there's just not that much to be had. In the tide pools in summer 2020, we saw an increase of limu, which was rare. We're not used to seeing that much. Because of that, we saw an increase in fish and herbivores that like to come in and graze on that. But of course, as soon as humans were able to come back into the Marine Life Conservation District, along with their trampling of the reef, all of that limu is gone again, unfortunately. And so finally, what does all of that mean? We want to continue monitoring efforts and documentation of the limu species. We want to ensure that limu remains abundant, predominantly native, and that there are adequate invertebrates enhancing their habitat. We would like to, in the future, control human impacts and eventually adjust the MLCD limu allotment to reflect availability and sustainability. Okay, that's all I have. Did I stay in my time?
You did great, Jenny. That's amazing. Yeah, I mean, it just makes me think about what the power of community, citizen science, and Kilo is. Jenny does this just as a labor of love for the MLCD, and she's learned from practitioners through the Limuhui and folks like Uncle Mac Poi Poi, who's on today. So thank you to Uncle Mac. Thank you to Limuhui, and thank you to Jenny for bringing that body of knowledge to Malama Pūpūkea-Waimea. All right, we are next going to turn to Dr. Dan.
Unlock. Share. All right. Thank you, everybody, for letting me join. So I'm going to give a quick introduction about our organization. We're new to this party. Most of you haven't heard of us as Kuleana Coral Restoration. Most of the data you're going to see that I'm presenting today has been collected within the last month, most of it within the last week or so. So it's very kind of quick and dirty at this point, but it'll give you kind of a representation of what we hope to do and kind of what we're capable of here in the at Sharks Cove. So. All right, so we're Kuleana Coral Restoration. We just started about a year ago, or maybe 2 years ago. Our goals are to restore damaged and degraded reefs by replanting corals. Ultimately around the island right now, we're working on the west side because that's where we're permitted to work. This is our organization that we started with, our founder Alika and myself and Kapono. We all kind of hail from different parts of the islands or different parts of the country. We have a lot of collaborators that we're starting to work with, Malama Pūpūkea-Waimea, Malama Manalua, and DAR, and HIMB, and so on. Okay, so our main focus of our organization is direct restoration. Now, in simple terms, what that means is we go and we collect broken and damaged coral and we simply put it back. Okay, in Hawaii, we have abundance of damaged coral from storms, from ship groundings, from anchor damage, and those typically are going to die. They have a very low chance of survival. We simply go find them. You can see here in our imagery where we go and we collect them off the bottom of the reef slope and we take them to a spot that we designated as a prime restoration site, and we simply glue them back to give them a second chance at survival. We focus on large colonies because they immediately restore a lot of ecological services. So that's where we put our effort. Here's a couple quick images of this Grandis colony that we replanted. And then on the bottom, we have one of our restoration sites, some before and after pictures of us, taking these large colonies and gluing them back to restore the coverage. Okay, now quickly we realized if we really want to measure our effectiveness at this and how in our long-term outcomes, we really need a good monitoring system. And so we picked up this same 3D mapping and mosaic modeling that many organizations around the world are starting to tap into. Now, it's actually a really simple process. This is me swimming over the reef with a couple of GoPros, continuously taking images. We generate maybe thousands of images per site. Then computationally, we take and reconstruct those back to make one large photo mosaic. Now, we have to go through the route of 3D modeling first, just so computationally it works. So that's what I'm going to talk about now. So that was me just basically you drive around like a lawnmower and you just comb the entire reef, taking lots of images. And the nice part about this is the resource you need is just a couple GoPros. So we're trying to bring it to community-based organizations, well, like ourselves, but other ones that really want to understand what their reefs are looking like Malama Pūpūkea-Waimea. And we can teach people how to collect this data. And it's pretty simple. You don't have to be a fish expert. You don't have to be a coral expert. Really, you just need to know how to swim. Okay, moving on. All right, so then once we've swam over the reef, we generate a map that looks something like this. Okay, so this is one of our sites over on the west side. This is a reef where we're restoring to the right side of this area where it's mostly degraded. That's a large scale view of it. And this image, this video illustrates how this process is done. Here you see a whole bunch of images. This is a single colony, just for an example. This is a single Pūpūkea-Waimea colony that I imaged. Basically, I swam around this colony and collected a whole bunch of images from different points. And then the computer can automatically align all these images and then figure out how they overlap to build a dense point cloud. And then it fills that in and you create a wireframe. And then you can go back to the original images and piece those in to generate a three-dimensional view of that coral head or that coral colony, right? So there's multiple colonies here. You see your meandrina, and then you have a couple Parietes lobatas that are attached to the base of that. Okay. Oh, play those. So what we're doing here is we're jumping in to Sharks Cove. Okay, I've been swimming at Sharks Cove and snorkeling at Sharks Cove for a very long time. I love this area, and talking to Jenny, she's like, oh yeah, we really want to understand, what's out there, what we have. And so we agreed to get in the water and just start to map it. We have a goal to map this entire, the entire cove with this type of 3D modeling. So here's one of the first images that we've taken. This site is right where most of the scuba divers that are going out on companies will come down right over this sand patch. This is the first big sand patch in the cove, about 20 feet deep or 15 feet deep. A lot of times they'll tie off their buoys to one of these rocks right here on the edge is typically where they'll anchor their dive float and then leave it to go on their dive. So the 3D maps are nice, but what we're really going for, well, the 3D maps are important, but what we're really going for, the real outcome of this is to be able to generate a flat photo mosaic. So we can get a detailed view down to colony resolution or, several, millimeter or centimeters resolution. So we can really analyze and understand what corals are present. So this is the areas that we've recently mapped in the last week or so. I'm currently running this larger section here in red, and we have some other spaces to fill in too that we've collected the data already for. My computer's just working hard on it. Our maps so far, they cover about just from this short effort, covers about 30,000 square feet of this cove. Now, the resolution of these images of our maps get pretty good. So we can get in and see individual colony counts. And if you can see this red dot in the middle, I'm going to zoom in on that red dot, and you can see the various corals that are covering that specific spot. Now I can zoom into any point on that entire map and get that same level of detail, and I can actually zoom further, and this is a low resolution image. I just didn't want to load the highest one because it makes my computer start to get slow. But as you can see that you can come in here and you can start to analyze these coral colonies, right? We can see lobata, we can see meandrina, there's some non-tipperan here, flavellata and capitata, and we can start to trace and map those out to get exact coral cover dimensions. Now this image on the right, this is one of our example restoration sites where we started to do this analysis. The colonies in red are the ones that we planted. The colonies in green here, these are ones that that was the existing coral cover. And so we see that from one of our restoration sites, we brought that cover in this sort of decimated region from 1.2% up to 8% in a matter of a couple of dives to restore that. And then, going from there, the idea is that these colonies will continue to grow and then start to fill that space out so our cover, achieves sort of the average cover around the island, which is closer to 12 to 20% for these healthier regions. Now, there's lots of questions you can imagine that we start asking with this data, right? So, it's immortalized. So once we image this, we can go back, that was September 2021 or September 22nd, 2021. So in the next, we can continue to monitor these areas and we can always come back and say, hey, what did our reef really look like in September 2021, right? We can find individual colonies and see if those colonies are still alive. and so on. So we can get our percent cover by, total percent cover and coverage by species. We can get this fine level of spatial distribution of different species. What are their depths? What are their habitats? We can look at co-localization of species. We can look at the size distribution of species. And then going forward, once we start to monitor this continually, maybe once every year or so, we can look at growth rates. We can look at colony turnover. We can document losses, or in best case scenario, we can document gains, both constitutive, which is sort of continual death. It's just natural and continual turnover, versus catastrophic, if we face some kind of bleaching event, or if we face some kind of ship grounding or something, that we really want to understand, what was the actual impact of that event. Now, and we can ask lots of questions that we don't really understand. Like, this is one example. I was looking at the data just last night, and there's these two rocks. This is about 25 feet deep, right as you go out into that sand channel. This one rock is covered very heavily with coral. The coral cover here is probably 40–50%. And then there's a rock just adjacent to that where the cover is much lower, maybe a handful of percent. So what is the difference between these two rocks that essentially look like they're the same depth, the same position? Now we can zoom in on that, and you can see that this one is mostly dead. You have one capitata colony encrusting here. And then the other one, you can zoom in and see sort of the abundance cover on this reef. Now, so if we look at that in 3 dimensions, you can see that this rock on the right, the one that's not covered, is a slightly lower profile. So it's a little bit closer to the sand versus the one on the left is close to the sand. The one on the right, where it's healthy, is slightly higher. Now, this sort of difference in topography, or this difference in elevation, probably saves this larger rock from sand scouring and getting buried during the large swell events that we get periodically through the winter. So this one gets basically decimated. This one that's slightly higher is sort of alleviated from that stress, which I thought was, kind of interesting, and, kind of interesting to, jump in and start to ask these questions and look at, what's really happening when we have this sort of level of detail of data. And once again, we have this data forever. And so going forward, we can really, first we want to get a baseline of what the cove really looks like. And then going forward, we can continue to monitor that and see, human impacts, wave impacts, storm impacts, et cetera, on these reefs, right? We can, some level of detail, we can map it very well, and we'll probably see a difference in cover at the access points used by most of the public. Or we can decide, do we see a sort of a decline in health at those different access points, for example, indicating, sort of this human impact, or does it look the same as the points that people don't necessarily access? And we can sort of gauge the level of sort of use and impact from all the tourists and divers and public that enjoy Sharks Cove so much. So I'd just like to stop there and say thank you, and pass the time on.
Wonderful. Wow, that was really fascinating. Thank you so much, Daniel. I know there were several questions that came through. So again, we're holding those to the end. Dr. Martini, if you want to look through and see if there's any that you want to respond to in the chat while we move on, feel free to do that as well. I think this was really new and different for a lot of folks. So really fascinating. Thank you so much. All right, so we've looked at fish, we've looked at corals, we've looked at limu, and now we're going to start turning to water itself, starting with Robert Walker. So Dr. Dan, if you can stop sharing your screen.
Sorry, I'm looking at the chat. My bad.
Sorry. No worries. All right. Turn it over to Robert Walker. Thank you.
Sorry, I forgot to unmute myself there. Okay. Wow, great presentations. That was really enjoyed that, and Daniel, you hadn't seen any of that new material, so really exciting stuff. Thanks for the opportunity to be here and be a part of this panel. My name's Rob Walker, and we're going to be talking about identifying submarine groundwater discharge in the Marine Life Conservation District. Would like to recognize my contributors on this project, Kostas Tomoulis and Benjamin Duncan, which are both here with us right now, as well on the Zoom, and Bernie Gonzalez, I don't believe he is. Just a little bit about Shoreline Conservation Initiative. We're a 501c3 nonprofit, started in 2018. We're based out of the North Shore, Haleiwa. Our focus is supporting coastal communities. We do a lot of coastal resilience work. My background is in coastal engineering and coastal geology, and our other expertise, we take a multidisciplinary approach to helping communities with coastal resilience planning. That's a lot of what we do. And a little bit of just kind of an introduction to submarine groundwater discharge. Groundwater exists, below the land and becomes submarine groundwater discharge anytime coastal aquifers come in direct contact with the ocean. And this is kind of a simplified hydrogeologic cross-section, just showing kind of a visual of how groundwater would flow into the tide pool area, for example. One of the reasons why we're really interested in groundwater, where groundwater is discharging is, anything that happens on land, whether that's contaminants from stormwater runoff or human waste contamination from septic tanks leaching into groundwater, that has the opportunity to get into the nearshore ecosystem, and in especially sensitive ecosystems such as the MLCD and in particular the tide pool area, that's kind of heightens that interest. And so just to kind of mention that there is historical knowledge of a good amount of groundwater in the MLCD area. 3 tables specifically is there's records that was used as a water source, where people Native Hawaiians would dive down and collect fresh water for use as groundwater or for drinking water. Just kind of a note on kilo observations. Anyone who's been snorkeling through the Sharks Cove area, you've likely felt changes in water temperature. As you're snorkeling by, you kind of hit a cold spot, and that very likely could be evidence of submarine groundwater discharge. This photo that Keelan Marcina took, where you can actually see kind of the visual distortion of the water column there, due to changes in density from groundwater compared to the surrounding waters there. This is kind of a unique photo. It's groundwater discharges. It's pretty challenging to really identify and map. And so as I talk about the results, I just kind of, I guess, first wanted to show this. This is kind of what we're after. Because groundwater is colder than the surrounding ocean water. One approach is to use thermal infrared cameras to kind of capture those differences in temperature. And so that's essentially what we've been working on the last couple of years, to take individual photos I'll jump to my next slide. Essentially, so we have a FLIR Pro R radiometric thermal infrared camera, and so we've attached that to unmanned aerial vehicles, UAVs or drones, as well as a fixed wing aircraft. And basically with the UAV, and this is a picture of the tide pool, just with an example flight path shown over it. Kind of similar to what Daniel's presentation was talking about. We're kind of going in a lawnmower fashion where we're collecting individual images, both the thermal infrared camera, and then we have a visual light or just a regular camera taking aerial photographs. And And so, you know, with the airplane, we basically fly passes over the MLCD back and forth, back and forth. We typically do, you know, anywhere from, you know, 6 or 8 every time we fly. And then from that, we have, you know, at least 2 or 3 good data sets. For the tide pool, we found a lot of success with the UAVs. And so most of the results that you'll see here from the tide pools are from the UAV. Another element that we added was, you know, we used ground control targets that were visual by the visual light photography, by the photographs, and then also with the thermal infrared cameras, we would place cold packs on those, and that helped in some cases to kind of georeference these 2 types of images together. And this image on the right here is essentially kind of in the middle of the process. Those dots representing, you know, individual photos, and then this is kind of the mosaicing process. And let's see. And then we also took manual measurements of temperature and salinity. So we kind of focused our initial phase of this work on the tide pool. That was kind of the area of most interest at that time. It was a little timely, and it was also just using the UAV because there's so much you know, topography within the tide pool and rocks sticking up. It really facilitated that process, and so it worked out really well. So yeah, I was just mentioning, you know, Keelan, his name came up previously. He was the you know, the science coordinator for MPW. He had taken quite a bit of salinity measurements within the tide pool, and then we took additional measurements, kind of complementing when we would be out doing our field work. And then I'll mention how we did the same for other areas. So here back is kind of looking at our bigger photomosaic, thermal photomosaic. This is from an airplane flight on May 8th of this year. And so I'm gonna jump to the tide pool real quick here. So basically, this is from August 20th, 2020. These were collected by UAV in the middle of the day. These colder areas are identified with these contours, and so this is, you know, essentially identifies 4 potential locations of submarine groundwater discharge, and yeah, the bluer colors representing the colder areas. And this data was then compared with the manual measurements of temperature and salinity. And so this is this figure here on the right is a combination of all the salinity measurements that had been taken. And we do see some agreement there, you know, with the areas that the thermal imaging had identified. And in addition, just anecdotal kind of evidence from MPW. The figure on the right are the black circles are locations where MPW staff had identified locations that they thought groundwater was discharging. And so we had that information, you know, at the beginning of our study, and then, you know, at least these 3 locations shown here seem to show a good agreement there. Back to the larger map here, we're going to dive in now and focus a little bit on the 3 tables area. You know, every outside of the tide pool has been really challenging to effectively accomplish our goals with the UAV. Just not having enough you know, reference points out in the water here at 3 tables and out here at Waimea. And so we've pretty much, you know, come to just rely on the airplane approach for outside of the tide pool. One thing that, you know, I will point out here, you know, it's just that we do kind of see in general colder water in the 3 tables and tide pool area compared to, you know, both sides. But this is a zoomed in view of 3 tables. The 3 tables would be out here. Surprisingly, just they continuously don't really show up in our thermal images. So this is the tide pools over here, and so these are areas. These are two isolated areas that that appear to be highly likely to be submarine groundwater discharge. And I'm trying to wrap it up here. This is from the UAV. We had 2 different UAVs flying on June 30th. And again, we see a colder region up here on the Kahuku side, as well as over here, on the Waimea side. And on this day, we also took manual measurements of temperature and salinity. And we have a spike of low salinity kind of in this corner here. But kind of hard to really for sure correlate that. It was a low wave day, but high winds, and there was a good amount of trade wind kind of surging through. And so, yeah, so there's 2 areas there. And just as far as next steps, we published a report in October 2020 focusing just on the tide pools, so that research could be used at that time. And then now we'll be in the process of writing a report covering the rest of the MLCD. And so it's like I ran a little late, but yeah, thanks again for the opportunity.
Oh, no worries. Thank you so much. This was really fascinating. And I love this combination of really high tech and community kilo, and even Rob just talked there about aligning some of what the Pūpūkea contractors or staff members have seen. And now we've got some science there, thermal imaging to correlate with our kilo observations as well. And excited to see where this information can help us better manage the MLCD too. So thank you so much. I think next we've got Dr. Henrietta Dulai, and I see Austin Ramos. Ah, there you are. Okay, perfect. All right, take it away. Thank you.
Aloha everyone, my name is Austin and I'm here with Dr. Henrietta Dulai, and we'll be covering submarine groundwater discharge as a pathway of wastewater contaminants into Kapo'o tide pools. So before we present, I wanted to acknowledge the NSF for funding this research, as well as the Malama Pūpūkea-Waimea organization for having us today. So to begin, in the state of Hawaii, there are many beaches that are threatened by poor water quality, and this problem is related to one major issue, and that is wastewater discharging into the environment. There are around 88,000 cesspools that discharge approximately 53 million gallons of untreated sewage into groundwater on a day-to-day basis. And because of this, we wanted to be able to trace wastewater and how it enters into the ocean. And we do this by investigating a primary pathway of wastewater, which is through submarine groundwater discharge, or SGD, as Rob explained and also depicted in figure 1. And in wastewater, you may have tracers such as pharmaceuticals, as well as elevated nutrients and stable isotopes of nitrogen. So our whole goal of this research was to examine if wastewater-derived elevated nutrient levels delivered by SGD are responsible for water quality degradation in the Kapo'o tide pools. And why we wanted to know this is to determine if any upstream cesspools or perhaps a nearby conversation seen in figure 2 are that source of excess nutrients. And also we wanted to identify how significant the flux of nutrients and other chemicals are in the pool. And onto our field investigation, we deployed a total of 4 techniques. 3 of those techniques were used to identify SGD by looking at radon, radium, and salinity as those tracers. We deployed 3 RAD7 radon monitors at sites 8, 9, and 10, depicted in figure 3 as those red dots. We utilized a CTD castaway to acquire salinity data and collected radium samples at sites 1 through 11. And for the 4th method, we collected water samples in order to characterize groundwater chemistry and its quality, utilizing a push point sampler and a peristaltic pump for sites 8 through 13. And in lab, we separated it into 4 parts. We used what's called a radix system that measured radium isotope activities. We performed a ELISA kit to measure the ibuprofen and caffeine concentrations in each of our water samples. And for the third and fourth parts, we sent off our remaining samples to distinct labs that had the appropriate instrumentations to measure what we were analyzing for. So in the results, we were able to create a map depicting salinity distribution across the pools. And notice that yellow signatures indicate low salinity, and that is where, that is in the northern part where that comfort station resides. And besides salinity being a great tracer for SGD, we've confirmed radon activities to be present at all of the 3 locations where we deployed those RAD7 monitors. And because we identified SGD at those specific locations, we then went ahead to calculate the discharge rates at those locations using what's called a radon mass balance provided by Dr. Dulai, which we computed values between the range of 0.5 through 0.8 cubic meters per meter square per day that is depicted in figure 5. And to continue on, I wanted to highlight 3 important details relating to the northern part of the tide pool about the chemistry and water quality. And we've indicated both the presence of ibuprofen and caffeine in the northern part. And because we were able to indicate those, the presence of those, we then went ahead to calculate a pharmaceutical flux, specifically the caffeine flux at station 9, which we computed to be 0.11 milligrams a day. And besides that, we've also determined the high nutrient levels. And what reassures that wastewater activity is prevalent in the northern part of the pool is our wastewater signature, that being our delta N15 of nitrate, was well within wastewater range. And this basically leads to the discussion and conclusion. Basically, this project confirms that SGD, as with its spatial distribution. And because of this, we then went ahead to calculate its discharge rates, which range from 0.5 to 0.8 cubic meters per meter square per day. And in this discharging water, particularly in the northern zone, we've indicated high levels of nutrients as well as low levels of ibuprofen and caffeine. And what reassures that wastewater activity is prevalent in the northern part is our wastewater signature confirming to be well within wastewater level. And to put together all of the results, this basically indicates that the comfort station and perhaps other wastewater sources located in the northern vicinity is contributing to wastewater and relevant nutrients. And in order to better understand SGD and the nutrient temporal trends, we need to establish further monitoring. And I'll be passing it up to Dr. Henrietta Dulai, who will be presenting on her part.
Thank you, Aston. If you could forward one slide. Yes, so first of all, we both would like to thank MPW for this great opportunity so that Aston could actually do his science project, the summer project, and learn about water quality issues that are prevalent across all of Hawaii, unfortunately. So thank you to Uncle Bob, Jenny, Keelan, Robert, Jenny, I'm sorry if I'm forgetting anyone, but they actually came out to the field, showed us around, explained so many things. So this was a great learning opportunity for Aston and myself as well. So I have worked at other sites along Hawaii, and the recurring theme is this wastewater. So when this issue came up, whether there might be a linkage to the tide pools from either the comfort station or even upstream development, that's how this project came about. And of course, I specialize in finding submarine groundwater discharge. That's why we heard so much about these radon radium tracers. And so I just wanted to put a little bit more perspective on this spatial distribution of the signature, and can we say more about the groundwater that's discharging. So I pretty much flipped the tide pool on its side so that now we have latitude, so the geographic coordinate latitude as our x-axis, and we will be looking at these different sections as what Aston alluded to, the southern and northern part. So the white line across the figure just simply means our x-axis on all of the next figures, and those vertical lines are pretty much aligned with the vertical lines on those figures as well. Aston, if you could please forward the slides. So what we see is that the stations in the northern part are a little bit different chemically than what they are in the southern part and the center. And so also all our stations were kind of focused along the shoreline, plus hitting some of those springs that Robert identified and shared the location with us. So I selected a few tracers, some that Aston did not describe, but I thought would be very indicative. So we also collected those, but it was already so much data that he presented on. So I also wanted to include those. So those are, for example, the stable isotopes of hydrogen and oxygen in the water that's discharging, silicate levels. So that is coming from the rocks, and all groundwater is enriched in it compared to the ocean, which is much lower. And then specifically total nitrogen as a representative of those nutrient loads. And then he already mentioned the delta N15 of nitrate, and I just plotted here ibuprofen caffeine is showing the same spatial trend. Wherever you see a star, so by silicate, total nitrogen, and the delta 18O, that means that those data have been salinity corrected. Just because, as you see on the top right figure, salinity is really high in the, let's call them springs or seeps that are in the northern and central part. So there the salinities are ranging from 25 to 30-ish. We have to correct for seawater mixing with groundwater, and that's why we use those salinity corrected silicate and nitrogen values as well. So the oxygen isotopes, actually, again, these are salinity corrected, so they are corrected for seawater that's mixed in. They also show this very wide range. Actually, this is a quite large range of values. Oxygen variation in the oxygen isotopes in groundwater comes from different rain elevation, where these springs and seeps are fed from how high up in the watershed. And we see that the springs in the north and the seeps have much lower signature than some of the other ones. So they are different. They are coming from higher upstream or a different watershed, as I will allude into. And same is shown with silica. They are much higher in silicate, which would be typical for its geology. Now, looking at this human use aspect, definitely total nitrogen levels of over 100 micromoles are that giveaway of something being not natural. And indeed, that's confirmed by the delta N15. So while we need to correct the nitrogen concentrations for that salinity mixture, the N15 does not need to be corrected because it's simply just the ratio in atoms. So even though those saltier wells seeps may experience dilution by ocean water, N15 does not get affected by that. And I put it a dotted line there, kind of where roughly that boundary is what we call wastewater. Some places that boundary is much lower, but here I think the values of 10 and 12 are definite giveaway that there is some denitrification going on, accompanied with having lots of organic matter in the water, which is typically wastewater. It doesn't have to be, but it could be manure or other sources. But then the further confirmation of that wastewater, as Aston already alluded into, are those pharmaceuticals that are in the water. And so those are also, they have pretty much a zero, of course, the detection limit as their limit, what we call wastewater. So I draw that dashed line in there. So definitely wastewater is confirmed in those parts in the northern section. Aston, if you could follow forward one more slide that shows kind of what we think is happening is that we have this on the southern part, we have groundwater discharge of higher salinity groundwater that has a lot of seawater mixed in. It also has lower nutrient concentrations even after we correct for that salinity mixing. There were no signs of wastewater signatures based on N15, and we didn't find any of those ibuprofen and caffeine concentrations that would indicate that. Of course, ibuprofen caffeine would be diluted by that seawater that's mixing into the groundwater, but N15, as I said, would not. So we think it's really kind of much the than the water in the north. So after hearing all these nice results about the fish and algae and the corals, I'm so sorry to be a bearer of bad news, but indeed the northern part so specifically sites 12 and 13, there we see that those N15 values and those pharmaceuticals that are indication of a wastewater signature. Fortunately, it's in the northern part where there is more mixing and it's more open to flushing to the environment. But certainly, these are a tiny data set in the big picture. As you understand, this was an undergraduate project, so there is so much to now build on. We understand that that's a location where we need to pay attention to. So we confirm the wastewater, that it is present, but we cannot tell whether it's coming from the comfort station or runoff from the showers or higher upstream in the aquifer. I would actually, based on the hydrological understanding of this setting, actually be trying to be looking at that coming from higher up in the aquifer. And I think that's all. We have one more slide that is thanking you and everyone from MPW.
Fantastic. Thank you so much. And yeah, it's amazing to have these results because I know that this was an area that folks at MPW just observationally thought might be an area in trouble. So now we've got some data to help us know what the next steps are. So that's fantastic. Okay, so this is the plan. We wanna hear from Kostas Stamoulis next, because Kosta's been listening to everything that we've all been listening to through the lens of human use and the impact of human use. So I want to go to Kosta, and then we've been sitting here for a while. We've taken a lot of amazing information in. So after Kosta, we're going to have like a 3-minute bio break for folks. Of course, do what you got to do if you need to take a little bit longer than that. But then we're going to come back and have a Q&A session with our scientists here. So Kosta first, then break, then don't leave, come back for more discussion. So Kosta, you know, the Pūpūkea MLCD, as we know, is heavily utilized by people. So given what you've heard here, can you just comment on the impacts of human use and maybe, you know, what we can do to address those impacts? No easy questions here today.
Yeah, thank you, Debbie. Yeah, I just want to say that it's been a really great number of talks today. I really learned a lot, and really looking at the MLCD from a lot of different angles, you know, from biological to physical, you know, groundwater to, you know, to fishes. So, you know, it's really, really interesting, and definitely learned a lot today. So I just want to thank all the presenters and of course, MPW, Debbie and Jenny for having me out. First, I guess I'll say, you know, want to kind of talk about human use, right? What are the potential impacts? And MPW as an organization has been collecting human use data in the MLCD for well over 10 years in all areas of the MLCD, but with most of that data focused in the Sharks Cove area. Over the years, I've been part of several studies in MLCD, focused on fish and corals, and have applied the human use data in that context. So, you know, I have used this data in the past, and hope to work with MPW to kind of take a closer look to see how that can inform, you know, management going forward. So, for a 2010 study, looking at spillover of fishery species with Alan, I relied on the MPW's human use data to estimate the level of fishing pressure inside the MLCD. In 2019, I was asked by MPW to replicate these 2010 surveys to see how coral and fish populations had changed over that time, and also looked at changes in human use over the same time period, so about a 10-year time period. So from that, that data showed that overall human use doubled between 2010 and 2019, shore-based human use tripled in the tide pool area, and the in-water human use was 10 times higher in the area in the waters outside the cove, the deeper water there where my survey sites were located. So that, you know, that alone is pretty astounding. So what are some of the potential impacts of human use in the MLCD? So I guess to answer this question, you know, we probably want to differentiate between the direct impacts of people sharing the same space as marine species, swimming and diving, walking on the reef, and from the indirect impacts of water quality, which are another type of human impact. So briefly, water quality impacts include sedimentation from erosion due to people walking on the shoreline, as an example. Sediments are known to smother and kill corals and other benthic organisms. And more recent research has shown them to also have impacts on fish behavior and health. And actually, MPW has been very successful in addressing erosion issues in the MLCD through their coastal restoration efforts. So they've done a lot to help with the sedimentation impacts. Another aspect of water quality that we heard about today was nutrients and pathogens from human wastewater coming through the groundwater. So, what do you do about that? This is a problem that needs to be addressed at the source. And I'm sure most here know about MPW and others' recent victory in court to stop a development with questionable wastewater plans from being implemented directly across the cove. So that was a big win for the fish and the benthos and the community organization here. There's a state mandate to upgrade all cesspools by 2050. So that will go a long way to addressing water quality issues in this area. But it's never too early to educate people and encourage conversions of existing cesspools. And, I was curious to know what, thinking about this, curious to know what type of system the comfort stations there have. And reading in the chat, it looks like there's a septic system there, but, it seems like there could be some potential impacts there. So that brings us to the direct impacts of too many humans in the water, otherwise known as tourism or recreational impacts. So these type of impacts can include breakage and tissue damage of coral and algae from trampling, trash and debris deposited in the marine environment. Sunscreen is a potential impact, though it's kind of controversial in the scientific community at this point. And finally, change of behavior of marine species due to too many humans basically getting in the way. So feeding and reproductive activities of fishes and other marine species can be disrupted by human presence, especially when you have, really crowded conditions. So, briefly, what can we do about it? Some of this can be addressed through education. You can teach people that corals are alive, for instance, and, a lot of people don't actually know that, so corals are alive, you shouldn't step on them. But in order to really address overcrowding, you really have to put rules in place and enforce them. In other words, implementing some type of limited entry system. So yeah, that's all I got for now. Just kind of try to address, what are some of the impacts and, some ideas about what can be done.
Wow, thank you so much. Okay, so we got our marching orders here from Costa. Education, go back to chapter 91, new rules, no problem. We know how to do that now. Yeah, continue the good work that MPW does in collaboration with all you fantastic people. Really appreciate those thoughts. And we're going to come back to that some more. But let's take about a 4-minute break because I see that it's about 36 after the hour. Oh, just turned to 37 after the hour. So 3-minute break. So 3 minutes, we'll come back and we'll start with some Q&A. So go take care of things and we'll see you back here in just a couple minutes.
Debbie, I'm so excited about all the questions that I'm seeing in the chat.
I know, me too. We've got a bunch and
We have a very
we've got,
smart audience.
yeah, and I'm just overwhelmed by everything that we've heard already today. It's been pretty, I don't know. I want to know how all of that can come together. How do we layer that all together?
Yeah. Exciting.
I learned so much. We'll just give everybody another minute. And actually, Jenny, I was thinking based on what Costa was just saying, if you wanted to give just like a little 2-minute on yours and Christy's observations during COVID, when he was talking about the behavior of the marine life in response to human use and how what you all saw as you observed so regularly during the closures and then when it opened back up again. I thought that might be interesting context for folks.
You mean like the
Sure.
giant school of a holy holy?
Yeah. Alan's favorite fish.
Aha, very good. Well,
Yes, of course.
why don't, do you want to, I know, some people may not be back yet, but I think we've got at least
Yeah, that's fine.
the bulk of us, but do you want to just share what you and Christy observed
Sure.
during
Yeah,
COVID?
so Christy's on here. Her name on her thing says Avian's iPad, but that's Christy. And again, my left arm. And so Christy and I were really kind of rebels back when we got put onto our lockdown for COVID. And Christy and I have spent so much time, not only, in our capacity with MPW, but we've both grown up here on the North Shore. So the Kapo'o tide pools is an area that we've known our whole lives. And so when the shutdown happened and all of a sudden there were so many few or literally zero people in the tide pools, we had to go, even though we weren't supposed to be going. So we snuck down behind the fire station and where nobody could see us and jumped in the water really fast because we figured once we got across the beach, then we were fair game in the water. And so we literally went every single day for months, that whole entire spring and summer, every single day. So we watched the marine life go from nothing, which is typical after, a lot of people have been in the tide pools, to all of a sudden, there were juvenile fish popping up everywhere. There was starting to be turf algae growing on every single surface. And it was actually something we had never seen before. And Christy's a limu nerd along with myself. And so we were like, whoa. And so we were starting to observe over time, behaviors of fish, just like what Debbie was alluding to, and Alan. All of a sudden there's these schools of a hole that we're watching grow and grow and grow around this one rock in the tide pools. And it was hundreds and hundreds of fish, and they started really little. And then by the end of summer, they were good sized fish already. Also the behavior of fish, they were coming right into our, Nanue were like following us. They were in literally every picture we took. So yeah, just the behavior completely, it seems like everything relaxed, everything started growing. We started seeing relationships among fish. We started seeing different species interacting amongst each other, whether they were hunting together or competing for food together. And so it was a very rare glimpse at what it looked like without all of that human impact. And then we slowly watched the human impact increase again. And we've watched it, this entire summer back down to decimated, I guess is the best word I can use. So it was a very unique opportunity to watch it go from really kind of crappy, for lack of a better word, to really amazing in a shorter amount of time, back down to really junk. But it showed us two things. One, the ecosystem is very resilient, which is, I guess, good news and bad news, because it did pop back really quickly. And the other thing is that if given the opportunity, if it would have stayed that way even longer, imagine the benefits that would have happened for the outlying areas of the MLCD, if the MLCD was really given a chance to do what it's designated to do. So yeah, I hope that answers your question, Debbie, about kind of a look at Christy and I's experience in the tide pools through that whole COVID situation.
Yeah, no, absolutely. I think it's really relevant to the fact that so many people thought human use was a key threat to the MLCD, and then hearing what we've heard today from the different presenters too, I thought it was relevant, definitely relevant information. So just to let people know how this next piece is going to work, we have you for about another 45 minutes if you're going to stay on with us. MPW is going to be a little bit selfish here with the Q&A because we invited all of these scientists to come so we could get some information about how we put all of this together for management purposes. So we're going to prioritize a couple of MPW questions first. And I see that Stacia Marco and Luna Kekoa are both here from DAR. So I told them I'd give them an opportunity to each ask a question if they have a question to ask. We're going to see if scientists have any questions to ask each other, and then we're going to go to, other questions that the audience has. So continue putting your questions in the chat. If a particular scientist can answer the question, or Jenny or whomever, feel free to answer in the chat as well. And so for each question that we as MPW have for our panelists, I'm going to just call on probably two. So if the scientists either want to physically raise your hand or use your little your reactions down there on your Zoom to raise your hand like I've just done. We're not going to have time to have each panelist answer each question, or we'd be here. I mean, I would love that, believe me, but we're going to call on a couple to answer each question. So my first question, easy question. What do you think, based on everything we've heard today, are reasonable goals for management? And what do you think are the highest priority management actions for us, given what we've heard today? So anybody from our panelists want to take on that management focus question? And I'm not afraid. I teach, and I've got 1.5 years of experience now teaching online, so I will call on people, just so you know. But I see Alan. Everybody's waiting for you to answer all the questions, Alan. So you take the first one.
The one that's going to come up with an unpopular answer, which is pretty much we need to regulate and limit human use in multiple ways, right? Water quality is definitely an issue. Part of that is a result of too many people, but as Costa alluded to, just having all those people in the water concentrated in small areas modifies the behavior of animals, trumps on the lemur, breaks the coral. So those are all kind of I would call those indirect, all of them. The direct one is people actually killing fish and taking them out of the water inside the MLCD. I mean, if you look at the legislation for MLCDs, they are supposed to be afforded the highest level of protection of any areas in Hawaii. And, the expansion and progress that was being made at Pūpūkea seems like it's backsliding now, just because I think there's a fair amount of things going on, both direct and indirect, that are affecting that.
All right, so we've got limiting human use, some regulations there, address the poaching that's happening. Anybody else from our panel today want to weigh in on this question of priority management actions? Oh, I see Paul, go for it.
I'll weigh in. Basically, it's like our Hanauma Bay situation. The shallow part is sacrificial land for tourists, whereas the outer reef is, nicer, and it's like less people go there. There are some snorkelers and some scuba operators that, if they want to track down their scuba gear, they do go to the outer part. So maybe looking at the tide pools, maybe in that same situation or same scenario, but it's bad. It's bad no matter what. But I agree with Alan, some type of carrying capacity study would be ideal. And if you can kind of live with it, have the tide pools as the area where the people congregate to kind of save the outer part, but you'll still have your scuba operators and you'll still have your snorkelers. So it's a similar, in my opinion, it's a similar situation in the two MLCDs.
Interesting. Okay, so we've got a pitch to prioritize other areas, recognizing that some human use is bound to happen. I'm going to give anybody else a chance from our panelists to weigh in on this. This is our biggest question, is what our management priority actions should be. So I feel fine. Oh, I think I see Dr. Dulai. Henrietta, do you want to?
Well, I just wanted to add, I guess, state the obvious that our coastline is so leaky, and we just cannot ignore the fact, now confirmed fact, that there is definitely wastewater seeping in from some sources, and that then gets into the land management, the watershed management as well. Of course, there will be upgrades to cesspools, but we have ongoing studies that show that our infrastructure, even sewer lines, if they exist, and then even well-working septic systems with sea level rise, they get inundated, they get flushed, and we see the same wastewater signature then coming out. So very, very careful planning from the state. And of course, the state is now working on prioritizing areas where to upgrade the cesspools. So maybe good time to get on the radar.
All right, that's great. Thank you so much. Okay, our second question is, how can we capitalize on traditional ecological knowledge and kilo for both scientific research and management? So we've seen a lot of kind of more high-tech approaches, and we'll get to that in a minute, but now we're really wondering, how can we really capitalize on our TEK and kilo for management? Jenny wants to answer that one. We'll start with Jenny and then Alan. Jenny first, then Alan.
Thanks, Alan, for letting me go first. You know, as someone who's been practicing kilo for a really long time, you know, I don't have a PhD behind my name, nor do I have a degree in science, but I do a lot of marine science through kilo. And something that I've really enjoyed about working with everyone here on the panel, especially Dr. Dulai and Dr. Friedlander, it was really beautiful to sort of see how the kilo was able to inform sort of the more traditional science and vice versa. And so I think that the more that scientists utilize kilo to get a more broad picture, a more holistic look at what's actually going on in a place, the more that kilo will then, you know, or folks who practice that traditional knowledge will be more willing to share it and be more willing to, you know, to collaborate. And so I see that as such an opportunity, and not just for us here at Pūpūkea, but across the board, you know, to have these two sort of justify each other and really make a broader, stronger look based on not just, you know, the scientific data, but also, you know, understanding the cycles and the relationships and the patterns and the, you know, all of that stuff that plays into it.
Wonderful. Thanks, Jenny. So we'll turn it to Alan, and then Rob also indicated that he'd like to weigh in on this one.
Sorry to jump in again. So this is in deference to Mac Poipoi, who's on the call here today, who I've learned an unbelievable amount about traditional knowledge and kilo, working with him in Molokai. And so I think the main thing that can be learned is pono fishing. Well, for me, at least, pono practices, right? Whether it's fishing or gathering limu, understanding like cycles and trends, times and seasons, when things spawn, where they spawn, how not to disrupt those processes, I think is key. And so that can only come from the knowledge that exists within the communities and within the broader community. Science can help validate some of that, but that knowledge is already there and really important because you know, once you break those cycles, then the wheels come off.
Yeah, thank you. So Rob chatted me that he'd like to say something, and then I'm going to turn to Whitney. So
Yeah.
Rob, go ahead.
Thank you. Yeah, I just wanted to mention, you know, as we kind of presented the submarine groundwater discharge mapping in the tide pool and how that was informed by kilo, you know, we could, I think, benefit from observational reports on the Three Tables area. You know, if if folks have from past, you know, time spent there, or, you know, targeted kind of citizen science, you know, going out there and just trying to, you know, feel and see if you can identify colder areas. You know, we were a little surprised around the Three Tables, not, you know, our thermal imaging approach not really showing, but not to say that there's not groundwater being discharged there. So both Kilo, and then also if if there is any additional information, historical kind of context that could be provided, if there is anything more specific than kind of what we already know.
Oh, fantastic. Thanks, Rob. And we're going to let Whitney have the last word on this one. Go, Whitney.
Thanks, Debbie. Yeah, both Jenny and Alan touched on, understanding cycles and kind of temporal patterns. And I think that's one thing that's really important with Kilo that can be missed with other scientific methods, is that you get this really full temporal observation over time. You can get information a lot more frequently than our once or twice a year scientific surveys. And so I think that also adds a really important component that can be otherwise missed as far as scientific knowledge and an understanding of an area, and particularly in a place like the North Shore, where you only have part of the year really that you can do scientific surveys. So so I think that is really important to recognize, that the value that brings to the table as well.
Thank you, Whitney. I appreciate that. Okay, so we're gonna go to the other side of the same coin now. And how can we capitalize on some of those technological advances for both scientific research and management? I think we've seen that some of the folks on the panel today are really bringing their high-tech game to this discussion. How can we capitalize on technology for management? Who wants to take this one? I might call on Dr. DiMartini and Laura. Okay, good. Laura, Dr. DiMartini, and then Laura. How's that sound?
Yeah, I was just about to raise my hand. I just couldn't find the button. Yeah, so, well, I think there's a lot of value in technology, and a lot of it's coming from this ridiculous computational power that everybody has on their laptops, on their GoPros, on their phones. And I think tapping into that is a really good way to go forward, right? So, I mean, what I showed you today, I mean, they look really cool in the 3-dimensional maps and everything, but honestly, like, it was a couple of GoPros and me swimming around. I mean, you need a little bit, and I processed it all on my laptop. Now you can streamline things by using supercomputers and all that, but really this was just done by accessing things that everybody already has. And so really one of our priorities and one of the things we're focusing on Kuleana is to bring this kind of like citizen sort of participation to other small groups and community groups and things, so they can help do this monitoring. I mean, dealing with all the data is a completely different story, but acquiring it, anybody can go out and do that. And we'd like to really get people involved doing that, because the more data you have, the more questions you can answer, the better picture you get of what's going on the reef and the ocean, et cetera.
All right, nice. I like that combination of the citizen science and the technology too. Okay, Dr. Gajdik, and then it looks like Costa.
I mean, really, that's like Dr. DiMartini said, like now the computational power is really amazing. And I'm going to bring like another type of new technology, if we can call it technology. It's called environmental DNA. It's getting really more and more popular right now in the scientific community to really, I mean, it's shown that it's really a great tool for monitoring too. And it's complementary to, for example, visual, surveys that are conducted by scuba divers, or using also cameras underwater. And I guess it could be useful in two ways for the MLCD. And one way is, when the wave action is really strong and, it's really difficult to send divers, then maybe, taking this water sample. So it's just, I mean, for people who don't know, sorry, I should have said this before, environmental DNA is kind of, if you take a bucket of water and then you look at all the DNA that's, molecule released by organisms, by cells or feces, and then from looking at a specific region of the DNA, you can actually, map this and really look at all of the species. And so, for example, it's, really hard to say. It's just you take a bit of water, of sediments, and then, you go back to the lab and then you do some sequencing, and it's becoming more and more cost effective. And in other way, it could be complementary of what species, Some of them are super elusive. Like we know that, sharks or anything else, when we jump into the water, they tend to just really go away. So it's a tool that, shown for New Caledonia when they really look, and for example, they had more and more tiger shark that they thought in the water. It could be also useful for cryptic species, any morays are really, hiding when you go on a transect, when you lay down your tape. So I guess it's something to be aware, and that could be useful. And right now it's really just complementary. I mean, right now it's not going to replace any surveys, and it's mainly presence absence, but it's more and more, people work more and more into trying to get abundance. And right now we don't have, size, so we can't really do any, biomass. But I just wanted to point it out there that it could be useful a certain way. And I mean, it's actually what we're trying to do with Dr. Kimberly Payton at DAR for estuaries. So, to see if it could be complementary to cast nets and BREF in that sense.
Fantastic. That's really interesting. I hadn't heard about that, and I can just put a plug in. I know MPW is always happy to be a pilot site if somebody wants to try something new in a new area. We're always looking for that kind of partnership. All right, Kosta, you've got the last word on this one.
Okay, technology.
I think maybe Kosta might be frozen. Oh, okay. I don't know.
Now?
Oh yeah, now try that, Kosta. Go for it.
Okay, let me try without my video, so at least you guys can hear me. My internet might be a little unstable. But basically, the point I want to make is that technology can really empower citizen and community science. One of the things that I worked on during my PhD is doing stereo video surveys of fishes. You can use it to look at abundance, but also fish behavior in terms of, like are fish avoiding humans or not, and we see differences inside and outside of MLCDs, for instance. But, this type of technology, like Dr. Dan alluded to, it's easy to collect the data. You could get community members out there with the video system and actually collecting the data in partnership with scientists, and to actually analyze the data and really do some interesting research in that way. Another thing that's really exciting in technology is this app-based data collection. There's so much you can do now with different types of apps and photos. An example of this I noticed the MPW human use data has now moved onto a Google form format. And so, that's something that can be, filled out on your iPhone when you're out there. So it's really streamlining data collection and, capturing that data. And you can expand on that and do more citizen science to get maybe other members of the community out there doing human use data counts on their phone, when they're able, and even such looking at enforcement. Alan alluded to poaching. Well, if there was an app and I think that DOBOR, or not DOBOR, but DLNR enforcement does actually have an app that you can download and make and sort of document any type of illegal activity. So getting these type of tools in the hands of the community and interested people can really empower a lot of data collection, and kind of also as a way to collect those observations, those kilo observations, to more documented traditional science.
Love it. And Jenny has put the DLNR tip app in the chat, so everybody in Hawaii should download that. So thank you, Kosta. All right, MPW has one more question, and then we're going to go to Luna and Stacia to see if they have a question. So our last question I mean, it's not our last question. It's the last question we're going to take up space for in this particular forum today. Where are the gaps? What are the gaps in our science? And I know that Alan wants to answer this one and Paul wants to answer this one too. So gaps in our science, you know, who should be at the table? Who should be at our virtual table here that we don't have at the table? So Alan and then Paul.
Yep. Sorry to raise my hand so quickly, but you gave us the question beforehand, so I got a chance to think about it. Most importantly, before we talk about what science is needed, we really need to talk about what are the goals of the MLCD. So the timing's really good because you guys are involved in developing a management plan for Pūpūkea MLCD, which is totally awesome because hardly any, if any, protected areas in the state really have adequate or management plans at all at this point. So it's a great thing. In my mind, the major gap is what are the drivers of change in the ecosystem? It's a North Shore exposed area, high wave energy environment, a lot of water movement for the most part. I think we should put climate change in the back burner. I mean, I think it's always over, you know, something we should talk about, but climate change is not going to affect everything universally. No, you know, Pūpūkea, North Shore's got low coral cover, which is typical of a North Shore location, you know, so it's not going to have, you know, a massive effect. It's more of a complex habitat because of the boulders and the reef topography, not necessarily the coral. All the coral that's there is pretty much just hanging on for dear life, right? It gets the crap kicked out of it every winter. So it's a different type of ecosystem. And, you know, we've got freshwater input, some of it natural, some of it not. And so the questions are, what are the drivers of change? We've got a lot of good pieces of the puzzle here, but putting it, I think the trick now is to get everybody to start to talk together to see, you know, what are the major influences of the ecosystem and, you know, what are the objectives and how do they correlate with management?
Yeah, key questions there. Thank you, Alan. And then Paul.
I should have gone first because Alan stole my answer already again. But basically, you know, as a fish person, I would like to kind of know fish movement. What happens to the fish during these high wave events? Where do they go? How do, you know, is the MLCD a sink or a source? You know, is there larvae coming in from other places or is it distributing larvae to other places and things like that? That type of data, that type of science, you know, as a fish person, I'm interested. Basically, you know, during the big winter swells, do they reside or do they move offshore or along the coast? Or, I mean, all along the coast is going to be high surf anyway. So where do these fish go? That's kind of like the data gap.
All right, thanks, Paul. And we're going to let Dr. Dan have the last word on this one.
Yeah, no, I'm just curious. I really like the survey everyone started out with on their opinion of what they think the major impacts on the cove and the MPA are. But what does sort of the data tell us on that? Like, is it really tourism that's a big problem? Is it, you know, local sort of overfishing? You know, what is sort of, where is the impact? And do we have like sort of science to sort of break that down or to stratify those and what our impacts really are?
We're getting there. We're trying, man. Yeah, those are exactly some of the questions we're trying to answer, is look very holistically across the ecosystem and see what those actual impacts are and where we need to prioritize. All right, thank you for addressing some of MPW's key questions. I do want to give Luna and Stacia an opportunity to ask a question too. Luna and Stacia are both working with DAR's Holomua 30 by 30 program. And so they're our close collaborators for the management planning process. So I'm not sure who's going first and second. Luna's going first. All right, Luna. Thanks for being here.
No, I was going to say mahalo for inviting us, because this is awesome to listen to the science behind what's happening and all the data that's being collected. And kind of, I'm the planner on our team, so I was connecting dots, and I think Costa hit it. Like, we were talking about like the human use, and I was like, oh, we need enforcement here. And I know Jenny is in Makaiwat, so I think having enforcement in something like this to provide those stats, because like Costa said, like all these different tips are being provided, and what is the kickback from that, so that we can see like, oh, where's the hot spots, and kind of like how you guys are putting like all the different ways that, you know, like the data is coming in. You can do the same thing with enforcement to like better, oh, you know what, if we just put somebody at 3 tables, they can cruise over there, and that's where a lot of people are accessing, right? And so I think bringing dog care just kind of broadens the picture of how you guys, it's the complete picture, because now you have the science, you have the managers here, and we need that enforcement piece. So now you have the complete management picture. So that was the one thing. Thanks, Costa, for bringing it up, and Jenny for plugging that in there. So that's my piece. Mahalo nui.
Mahalo. And I know Jenny can tell you some of the very specific spots where the poaching is happening on a regular basis. Stacia, did you have a question or a comment?
I do have a question. So we've been thinking a lot about management plans with Pūpūkea in particular, but statewide with all of our existing areas, we're dusting off these ideas and trying to put them to paper. And then we'll be in the future going back out with communities and going through a process to go through them and share knowledge back and forth to make them the best management plans they can be, because as Alan mentioned, there is a dearth of management plans for the number of existing areas in the state, so we're working on that. That being said, part of the management plans, of course, are, you know, how do we reduce threats and impacts? But the other part is like, how do we measure success? And there's a lot of work that's being done on the fishery side, and there's of course still lots of work to be done, but looking at stock assessments and how do we measure biomass over time, and like the graphic that was shared showing different size classes over time and showing if the fish are getting bigger or smaller, for example, by species. But I feel like less so has been done for corals, especially when we take into consideration potential impacts from climate change. Now we have at Pūpūkea in particular, we're talking about trampling and people trampling the reef, plus you're on the North Shore, so there's all these wave impacts anyway. And so I was just kind of wanted to pick the panel's brain on what you feel like are good management targets or kind of sustainability targets for the benthic communities when we take all of these different threats and impacts into consideration. I mean, obviously the first level of the management plan is how do we reduce these threats and impacts? But further, you know, and I feel like a lot of people on the panel today have shared a lot of really cool technology and cool research that shows how we could measure changes over time, which is wonderful. And so then I guess my question is, how do we take it to the next level? How do we know if we've reached a point in which we're kind of at a sustainable level with our benthic communities by addressing all of these threats and concerns?
Awesome question. Any responses from our panelists? Oh, okay, great, awesome. We've got Dr. DiMartini and then Dr. Friedlander.
Yeah, and I think really the key is to have a good resolution of what we already have, right? I mean, I showed you some of the imagery we took, and you know, going forward, that's just dated this month, so we don't really have any historical data to look at for that at that sort of level. So just going forward, really, we just have to monitor it over in the future, and then eventually, I think we can start to ascertain what sort of the impacts are, where the impacts are on the benthos. I mean, there's a lot of data already that we can sort of tap for that, but the data I showed, we don't have any history yet. But we're planning on, continuing that effort so we can see it over time. I mean, hopefully it's not going to be too late at that point. But yeah.
Thank you. Dr. Friedlander?
Sure. So yeah, just to reiterate what I said before, it's a North Shore location. So we have to temper our enthusiasm for what it's going to look like and what it should look like. Fortunately, we've amassed a data set of all the benthic cover data that exists for the Hawaiian archipelago. And so we can compare apples to apples at this point. So North Shore location should be compared to other North Shore locations, not to, leeward sides where you're going to have less wave energy and higher carbon. So, compare it like that way, but also changes over time, right? We've got data from 2003. Costa's collected some data. We've collected some additional data recently that we have not analyzed yet. And And then Daniel's stuff can have a huge benefit because of the scale of the resolution there is amazing and much easier to acquire than having to jump in the water sometimes. So I think from the, and the stuff that Jenny and everyone else is collecting on Limu, I think is really interesting and important to note over time, especially if we're going to start to see more invasives pop up. So there's no, I think, one right answer. It's just a matter of making sure it's held in the context of what it should be, not trying to make it something that it's not.
Thank you, Alan. And thank you, Luna and Stacia, again for those questions and for being here and for helping us with the management plan and for leading that effort statewide. That's really important. So we want to give an opportunity for panelists to ask each other questions, because our high level question at MPW is like, how do we take all of this together to inform management? Like, what does this mean and how does it overlay? So my assumption, I guess, is that as you all were watching each other's presentations, that was triggering questions in your minds around what Dr. Dulai and Asin shared has to do with, what your data is showing. Do you all have any questions for each other? Does anybody want to raise their hand and ask any of the other panelists any questions? We can do a couple of these. Oh, I see Dr. Dulai with a quick on the draw.
Oh, I was totally fascinated. I mean, with all the research, but Dr. DeMartini's imagery, I wondered if once you make it representing a wider area, perhaps these underwater springs could be identified. Do you think that could be a potential option?
I think so. I mean, I definitely think it's possible. I know there are some, a lot of times, when you have those springs, you generally have some kind of void spot of coral and, cover in that sort of zone where that fresh water is coming in. So I think possibly, especially, at least we could sort of collaborate what you're finding with your isotopic analysis and stuff. Hopefully, I'm not sure. I guess, go forward, maybe.
Sounds like a connection. All right, I see Paul.
Is there any correlation between the number of tourists and nutrients or discharge in the tide pools?
All right, this sounds like a Dr. Dulai and Rob Walker question.
And Costa, because he's been dealing with the human use.
Thank you, and Costa.
I might pass it on because we did a snapshot measurement as just to understand the spatial variability. So someone who has been looking at the site for a longer period and has been doing those measurements would have the answer.
Costa, do you want to weigh in?
Yeah, I don't think we have the answer to that question right now. But I think the main thing is, we have this long-term data set on human use and being able to match that with some water quality information. And I know that there has been, Surfrider and possibly others have been doing regular monitoring. And so it's really, matching those two things together. And to be able to answer that question, and it hasn't been done yet, but it's totally possible. And for that matter, there's a lot of potential to compare the human use data that MPAW has collected with different parameters, in the tide pool, whether it's biological or physical or chemical, to look at patterns. And so I think that's an exciting area for research moving forward.
And we're going to be following up with a conversation with Costa, and maybe you can continue helping us connect those dots. And Jenny, I see your hand raised.
Absolutely.
Yeah, when Paul asked that question, the first thing I thought of is, Christy's going to crack up when she hears me say this. We were there above the tide pools near the showers, and it was a very crowded. I mean, it was like elbow to elbow people in the tide pools and in the park and up around the shower. And Christy and I were rinsing off our feet, and there was this mom, and she had tourist mom, and she had a couple of kids with floaties, and they had just come out of the water, and the one had about 2 years old, had a diarrhea blowout up the back, down both legs. I mean, it was super impressive. And she was just rinsing that baby off in the shower, and that water was just going right down into the tide pools, through the rocks. I don't know how much of it got filtered before it ended up right there where Dr. Julai found an increase in contaminants, because that's right where it goes. But I would definitely say that an increase in visitors definitely has some correlation with an increase in contaminants in the water, at least there anyway.
Yes, Jenny has lots of observational evidence when it comes to that. Yeah. Oh, Dr. Friedlander, go for it.
That reminded me of something that seems like it could be a fairly quick fix. When we were up there this summer with Whitney, and we got caught in a giant deluge downpour when we were in the water, and the path going down looked like a river of mud, right? And so all these other things are almost minini compared to a big input event like that, and fairly easy to somewhat mitigate. Put in some stairs. I mean, you know, the replanting, native replanting effort has been laudable and great, but you know, as long as you still have that avenue for all that stuff to come down, it's a giant mess. It seems like moderately quick fix.
So MPW has a dreamscape, and definitely that's on our dreamscape. And that just tells me that the county we should have invited the county to the conversation too, because that's been the barrier to that dream becoming reality. But yes, the streams of water that come down from those eroded paths for sure. I want to get to a question too in the chat. Uncle Bob has asked, I love this question, regarding increased use outside the cove. Okay, as water gets deeper, to what extent do these impacts that we're talking about get diluted? So at what depth do they become negligible? Is there a depth at which they become negligible? Does that make sense? So does anybody want to comment on impacts as things get deeper, as water gets deeper, and if that's a management strategy we should be looking at?
I mean, I guess, you know, I can just briefly say that, yeah, as water gets deeper, you know, you have more mixing. And so any type of contaminants are going to be diluted quite a bit. So, you know, that's one reason why more shallow areas like the tide pools are a lot more vulnerable to, you know, these to whether it's sediments or nutrients or pathogens coming through the groundwater. That water doesn't get flushed out as often, and it kind of sits in one place for a longer period of time. And so then those type of pollution impacts are exacerbated to those communities there. So deep water is good to mitigate those type of impacts. Yes.
Not to put you on the spot, Costa or anybody else, I'm curious then about the management strategy that Paul suggested toward the beginning of our Q&A period, which was, do you give up nearshore areas to prioritize areas that are less impacted by human use? Maybe I'm opening a can of worms with that. I don't know. Who's brave enough to take that one on? I see Costa, and then I'll go over to Dr. DiMartini.
Yeah, well, that's a tricky one, because the deeper water, you know, as I just mentioned, you know, you have that natural protection from deeper water, you know, more mixing, and so in a way, those areas protect themselves to a certain extent. You know, they're less vulnerable to not only pollution but also to human impacts, because there's going to be a lot less people that can reach the bottom. You can't walk around in deeper water. And so it's going to limit a lot of different impacts. So, you know, there's the other way to look at that is that, well, maybe we need to put more protection on the shallow, more vulnerable areas like the tide pools, because those are actually the most vulnerable areas.
Thank you, Costa. All right, Dr. Dan.
Yeah, it's a pretty complicated question. It really is going to depend on the specific organism that you're discussing, right? So like fish, for example, like if you get in the cove and just overfish the cove, you know, for, you know, uhu or whatever, that's going to affect the uhu all around, right? Because they have some range of mobility. You know, some of the, you know, the like the lemur, et cetera, like that's not going to move around. So sort of the impacts on either of those, you know, deep water versus shallow water, it's going to be completely different, you know, based on the mobility and the mobility of the tourists, you know, the sort of specific impact. So it really comes down to like a sort of a species by species question. So I think there is still value, a lot of value in protecting the shallow water as well as the deep water. But maybe you have to break it down by species and your specific goals.
Excellent point. It's complicated, isn't it? It's very complicated, but that's why it's really been awesome to have everybody on this call together. And I just wanted to make sure that we point out, Christina Comfort is here with Surfrider Foundation, and they're also doing water quality monitoring. And I see some activity in the chat around some, you know, maybe trying to coordinate some site-based collaborations there. So, so that's awesome. That's a great, if something from this conversation is able to improve that, that's great too. But I see that we're almost to the end of our time. So just wanted to summarize a little bit of what I've heard today. I learned so much. I heard a lot. I still welcome our science and traditional ecological knowledge partners to continue helping us make sense of how all of this builds together to inform management, because I think that's a really key question for us. It's wonderful that we know all these things and that we're learning more all the time, but how do we translate that to action and movement to try to make a better, healthier, more resilient marine life conservation district and surrounding coastal ecosystem? So MPW is a really small organization. Jenny's our only staff member and she's not even full-time. And then we've got some contractors like Christy and Samantha and me that help out here and there. We couldn't do this without funding from people like Patagonia, from WSL Pure, and we certainly couldn't do it without the generous participation and collaboration from all of these scientists. Most of them either found their own funding to do these studies or cut rates, or I don't know, we begged, borrowed, and stole. That's what I can say. And we are coming with such deep gratitude for the work that has been done and what it teaches us and how it helps us do better and move forward. So just want to thank everybody and recognize that not just the panelists here today, but the folks from DAR, Uncle Mac, and Surfrider, and so many people have collaborated with MPW to get us where we are today and are helping us look into the future to do the work we want to do. So thank you so much. It sounds like we still have our work cut out for us. Human use is a big concern. Trying to figure out some species that we can identify as priority indicators might be something that's moving forward. Building up our citizen science even more, maybe through some of those apps, app-based opportunities, continuing to create a bridge between Kilo and observational citizen science and, you know, professional academic PhD level science. Sounds like a continuing path forward for us as well. I know I'm going to have to come back and watch this recording about a dozen more times to glean from it what we want to glean from it. So just want to again end with thanking everybody for participating today. Apologies that we couldn't get to all the different questions in the chat. We hope that we sparked conversations that people can continue to follow up on together. And we haven't done this yet. Can we just all give a big round of applause or put your little reactions on your Zoom windows to say thank you to our panelists and discussants today, and really, really just appreciate all the work that you all do to help make the MLCD a resilient place. Hope everybody has a great day.
Mahalo.
Mahalo, Debbie. Thank you for moderating and keeping us all in line today. Appreciate it very much. And mahalo to all our panelists. And we'll hang out in case anybody else has anything else. But if not, thank you so much for joining us on behalf of MPW and our team and our ohana. Mahalo nui.
Thanks, everyone.
Thanks for hanging out, Uncle John. It was so good to see you. Awesome. Thanks, Rob. See you later. Thanks, Luna.
I think Luna
Thanks,
may have
Christy.
had to step away. Yeah, thanks, Christy.
Oh, let's stop recording.
Oh, yeah.